have radioactivity today. Radioactivity is the spontaneous disintegration, the spontaneous decay or disintegration of unstable atomic nuclei with the emission of alpha, beta, and gamma radiations with release of heat or energy. That is radioactivity. So it was in 1896 a French scientist called Henri Becquerel. He discovered that uranium atom can emit radiations of alpha, beta, and gamma. And he also discovered that X-rays can penetrate through paper and similar opaque materials. In the year 1898, another scientist, Marie Curie, in 1898, she discovered that radium is even more active than uranium in emitting such radiations. So these elements of uranium, radium, thorium that can emit such radiations are called radioactive elements. Why do atoms decay? Why do atoms disintegrate? They do so because their nucleus may contain too many protons and too many neutrons, and thereby leading the atoms to disintegrate, to decay, to split, to decay or disintegrate. So this is why atoms decay or disintegrate. And when an experiment was conducted using magnetic field, then it was noticed that alpha was slightly deflected, beta was undeflected, beta was strongly deflected, and gamma was undeflected. Likewise, when a radium sample, because they use radium sample with the block of lead and photographic plates, radium sample, block of lead, and photographic plate using magnetic field. So using the magnetic field, it was they discovered that alpha was slightly deflected, gamma was undeflected, and beta was strongly deflected. Likewise, using electric field, alpha was slightly deflected, gamma was undeflected, and beta was strongly deflected. So therefore, using both the magnetic and electric field, so there was very slight deflection of alpha, there were no deflection of gamma, and there was strongly deflection of beta. So when both magnetic and electric field were used, alpha was slightly deflected, gamma was undeflected, and beta was strongly deflected. So this diagram is showing the deflection of radioactive radiation in magnetic field, where alpha was slightly deflected and gamma was undeflected, beta was strongly deflected, and using photographic plates and radium sample. This is a radium sample in the lead of blood, in the blood lead, and this is the photographic plate. So, and therefore, this is the north and the south pole magnets. So using magnetic field, that is what happened. Alpha was strongly deflected, gamma was undeflected, and beta was strongly deflected. So therefore, using electric field, alpha was slightly deflected, beta was strongly deflected, and gamma was undeflected. So using both the electric and magnetic field, there were no deflection of gamma because gamma has no charge. It is neutral and it does not affect the atomic or mass number. It doesn't affect the atomic or mass number. It is neutral. So that is why it is not deflected. It is uncharged. It is neutral. That is what we have today. and I'll stop here at this point and say bye for now. We call it a day.